His question is asking a Gaussian distributed random variable x of 0 mean and variance sigma x square is transformed by a piecewise linear rectifier characterized by the input output relation. See the figure, here's the picture provided, and also they have given the piecewise function that x is x when x is greater than or equal to 0, and y is 0 when x is less than 0. The probability density function of the new random variable y is described by fy of y is 0 when y is less than 0, and k delta y when y is equal to 0, and 1 over square root of 2 phi sigma x exponential e power minus y square over 2 sigma x square when y is greater than 0. And the A part is asking, explain the physical reasons for the functional form of this result. And B part is asking, determine the value of the constant k by which the delta function delta y is weighted. Okay, now let's see how to do this. So first, if you look at the graph, we are doing the A part of this. If you look at the graph, that is 0, and this graph is like starting like this and going with the slope of 1, because y is equal to x, mean if x is 1, y is also 1, x is 2, so it has a slope of 1. And this one is 0 when the x is 0, y is 0 when x is 0, and also when x is less than 0, y is 0 as well. Okay, so based on that we can write this statement. The input at x is the input at x is less than or equal to 0 are mapped to y is equal to 0 as the probability for x is for x greater than 0 is unchanged. Thus, the probability density for the x less than or equal to 0 must be concentrate at y is equal to 0. Okay, and that's the answer for the A part of this question. And the B part is asking, determine the value of the constant k by which the delta function delta of y is weighted. Okay, let's look at that. So in the B part, we have to find out what's the k value, that is multiplied by this delta y right here. Okay, in order to do this one, we have to know this expression. As we know, the expression integral negative infinity to infinity f of fx of x dx is equal to 1. Here fx of x is even function, because as fy of y is a probability distribution. Hence its integral must also equal 1. Integral 0 to infinity fx of x dx is equal to 0.5, and integral 0 to infinity, it's because when we take 0 to infinity, that's like half of it. Here we are taking negative infinity to infinity, so if you take 0 to infinity, that's half of it. So f of x is fx of x dx 0.5, and 0 to infinity fy of y dy also 0.5, because both of them are equal. Thus the integral of the delta function must be 0.5. The value of the constant k must also be 0.5. Okay, and that's it for this question. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.